Hello everyone, welcome to the first lecture of our course on building planning and drawing using AutoCAD. So obviously this is a course on which we'll be using AutoCAD software for making the building plans and different other drawings. But before getting into the software part or before getting into the drawing part, we need to understand the basics of engineering drawing, which we have studied already in our engineering curriculum. So we will brush up few things first, and then we will jump into the software or jump into the planning and drawing part. Okay, so in this first lecture, what we will understand where we need to put these drawings that we will be creating. So the first concern for us is uh, where to put these drawings. So obviously these drawings will be putting in a paper, right, which we will be delivering to the site for execution. So first of all, our concern is paper. Okay, so what we need to do, first of all, we need to understand what sizes of paper are available and how to utilize those papers actually for printing, or you can say for plotting the drawings that we'll be producing, okay, for our construction work. So what we need to understand first, we need to understand the paper size. Let me just take the eraser. So here we need to understand the paper size, different paper sizes and their uses. Okay, how we gonna use those papers actually. Okay, then we need to understand obviously when we'll be printing or we'll be plotting our drawings, so there will be some norms regarding the drawings, because you see, when we have, suppose we have a building like this, okay, and then this particular area is something around, suppose 50 meter by maybe 90 meter. Now this 50 meter by 90 meter is not possible to plot on the paper, right? Because we will not get a paper of this particular size. This is totally impractical. So what we need to do, we need to represent this 50 meter by 90 meter area in our paper in a different dimension. Okay, so but when we'll be giving it to the construction site for execution, the laborer or the person who will be working in the site, he must understand that whatever box I have given, or whatever you can say drawings I have given, this is representing the dimensions which I have mentioned here. Okay, so what we need to do, this bigger size plot, we need to reduce the I could say size of it, keeping the dimensions same. So this particular process of reducing the dimension and keeping it same on the paper is called scaling. In some cases we need to increase the scale also. Suppose we have a we have a suppose area of 1 mm, or we have a box of 1 mm by 1 mm. Now when we are printing it in a A0 paper, I will explain what is A0 paper. It is a bigger size paper. In that case it may be hardly visible. So what we need to do, we need to scale the dimensions, but the representation will be same. It will be representing 1 mm by 1 mm only, but we need to increase the, you can say, view of this particular you can say object, right? So this particular thing is called scaling. So in that case, this scaling will be like expanding or reducing. Okay, so suppose expand or reduction, there are different engineering terms we will be explaining actually regarding this expanding and reduction of the scale. Okay, so this thing we need to understand. Then there are norms to keep the, suppose I have written this 50 meter by 90 meter, so this is my dimensions, right? These are my dimensions. So now this dimension text that I have written here, 50 meter and here 90 meter, obviously this will have a dimension also. Okay, now to suppose I'm putting it in a A4 size paper. Now I will be explaining what is the size of A4 size paper. Now when I'm plotting this box here and I'll be writing 50 meter or 90 meter here, obviously these sizes or these dimensions should be visible clearly to the person who will be walking by seeing this particular drawing, right? So what are the, you can say, proper sizes that we need to keep for these texts in the dimension? Or if you are writing something on the drawing, to explain some areas, particular areas, so those texts will be having some, I can say, heights, or you can say dimensions. So we need to understand the text dimension sizes. Okay, so the standard sizes we will see. Then this particular drawing sheet, if we all have already worked out, so the drawing sheets will have some information regarding the drawing, regarding the revision of the drawing. Like suppose you have made some drawing and there is some mistake in the drawing, or some changes need to be made as per the requirement of the site, so you'll be making it again, you can say incorporating those changes, so it will be a different revision. So these informations need to be mentioned in the drawing, so that any person, suppose in your in a construction site, one engineer is working and he left the company and another engineer joined, so he or she must understand by seeing the drawing whether this is a revised drawing or this is an old drawing, what are the informations, like who have made the drawing, everything should be mentioned in the drawing. So these informations are mentioned in the title box. Okay, title box. So this title box, obviously the name itself is self-explanatory. It will be having the title of the drawing, that means the name of the drawing, the sheet number, how many sheets are available for this particular drawing, and different other informations. So these are the few basic things we need to understand before getting into the drawing, right? And again, one more thing is very important. This is the line thickness. Line thickness. Suppose you have a wall like this, okay, then you have some road here, okay, or maybe you have you can say some, you can say section lines here. Okay, continue, like it is explaining the, like it is saying that this particular road is continuing in this particular site, right? We have shown only the a, a, a portion of the road. So what will be the thickness of these lines, whether to, how to mention the line thickness for the walls, how to mention the line thickness for other objects. Okay, there should be a difference between these line thicknesses, how we need to provide those. So these things also we need to know before making the drawing. Okay, then there are different line types, line thickness and types. Like we have dashed lines like this, we have dashed and dot lines like this, we have continuous lines like this, we have dotted lines like this. Okay, so there are, we have zigzag lines like this. Okay, we have very thin line, we have very thick line. So these things we need to understand where to use which type of line, or which you can say thickness of line. Okay, so these are the things we have already studied in our engineering drawing, or you can say building planning and drawing, but again I'm brushing it up before starting the drawing in AutoCAD. Okay, so let me show you some references from which you can basically get these ideas. So I will just open a PDF. This is engineering drawing practice for schools and colleges, SP46 2003. Okay, so I'm not sure whether there is a revision of this, but this is SP46. You can always search in the Google and you can find it out. So this particular you can say reference, it will give you some idea regarding the engineering drawing requirements. Okay, the standard requirements. So you can see the engineering drawing practice for schools and colleges. It is published by Bureau of Indian Standard. So here at the very beginning, what I will show you is the paper sizes. So why paper sizes are important? Because this is the thing where you will be putting your drawings, and it will be going to the site through these papers. Okay, so that's why in which paper you need to print the drawing, and accordingly you need to maintain every single thing in the drawing, like starting from the line thickness, the text height, okay, the text sizes, the dimension sizes. So everything will be maintained according to the paper size you are using. Okay, so starting from the biggest size that will be we used to use in a construction drawing. So this is nothing but A0. So if you see here, this is very simple thing, you can understand very easily. So the size of A0 is 841 by 1189. So if you see here, this dimension is nothing but, let me take a different color. So this dimension is nothing but 841. Okay, and this dimension is nothing but 1189, and again this is in mm. Okay, so these dimensions are in mm. Okay, so now you can easily reduce. Suppose you have A0 841 by 1189. So this is my A0 paper. Now if you just fold it in half, so how much it will be? How much it will be? So now it will be, if you see here, very you can say easily you can understand, so that this is the same 841, but it will become 594. Is it right? Am I right? 594. If you just divide this 1189 by 2, how much it will be? Will it be 594? Just check once. So here it will be 1189 divided by 2. You can see 594.5 is something. So here you can see this dimension I am getting 594.5. So if you are folding it in half, then you will get a paper size which is called A1. Now you got the A1 paper like this, or you can also rotate this in landscape. Now if you make it half, now how much it will be? This dimension will be fixed, which is 594. Now here it will become 841 divided by 2, right? So 841 divided by 2, so it will be 420. Now I have got my A2 size, you can see here. Okay, now again if you fold it in half, so this 420 will be fixed, and half of this 594 divided by 2, so 297, you can see. So now it will become A3. Now again if you you can say fold the A3 in half, it will become A4. So like this we are having the drawing sheet dimensions here. You can see very this uh, image is very self-explanatory. You can see the A0, we have folded it in half, we got A1. Then again if we have folded in the lengthwise, okay, the longer direction wise we'll be folding, so then we'll be getting A2. Then if you fold it in this direction, we'll get A3. Again we are folding it in longer direction, we'll be getting A4. Okay, so these are the standard paper sizes that we use for our for plotting our drawings, and you can say for sending it to the site. So you can see the dimensions of the different paper sizes. A0 is 841 by 1189. A1 is 594 by 841. A2 is 420 by 594. And similarly we got A3 and A4 also. This is the smallest size we have got, A4. Okay, so in bigger construction sites we hardly use A4 sizes. Most of the cases we go for A0 and A1, and in few cases we also use A3 and A2 also. But A4 sizes are hardly used in some places. In small villages, this A4 size may be used for, you can say, submission drawing and all. But in most of the cases you will find that the hard mostly used drawing paper sizes are A0 and A1. Okay, A2 and A3. Okay, some part drawings are also, you can say, printed in A2, A3 too. Okay, so these are the very, you can say, if you just download this particular code SP46, I will also provide you so that you can read it up. So there are different, you can say, formulas are given. The theoretical part you can read it out and you can understand. Actually, I'm not going to explain this. Then the next thing I'll be talking about, as I have written here, is the scaling. Okay, so as I already explained here, that when we have a, obviously we'll be having bigger plots, bigger rooms. So suppose we have a 10 feet by 10 feet room, 3 meter by 3 meter room. So obviously you cannot plot 3 meter by 3 meters in a paper. It is not possible to have such sizes of paper, right? So what we need to do, we need to reduce the size of 3 meter by 3 meter. You can say the represent, we have to represent this 3 meter by 3 meter room in such a way that it is the similar box that we are getting, but the dimensions we will be writing 3 meter by 3 meter, but it is not exactly 3 meter by 3 meter in the paper, right? Obviously 3 meter by 3 meter is not possible to get in the paper. So that means we are making some representation of that 3 meter. So what we are doing, actually we are scaling it down. Okay, suppose this is basically 1 meter in not 1 meter, suppose it is 10 in paper, and in the real case it is 3 meter. Okay, 3 meter means 3000 So what is the scale factor that we have used to scale it down? What is the scale factor? So we have used a scale factor of you can say, so we have made 10 by 3000, right? This is the scale factor. So 1 by 300, so that means we can say 1 is to 300 scale we have used. Okay, let me take let me explain it in a different way. So suppose I have a box of 3 meter by 3 meter. Okay, and here I have got a paper which is of A4 size. Okay, so obviously A4 size is just, as we have already seen here, A4 size is just 210 by 297. So the dimension here, it is 210 by 297 So obviously this this particular plot of 3000 by 3000 can't be drawn here in a such a small size paper, right? So what to do? We can reduce this dimension, but when we are reducing this dimension, the same reduction should be made in this side also, right? So that the similarity will be maintained. Okay, so how we can do that? So suppose I am considering that here whatever is 1 meter, suppose 1 meter in the real case, this is my real scenario and this is my drawing. Okay, 1 meter in the real case will be 10 in my drawing. Okay, 1 meter in my real case will be 10 mm in my drawing. So in this case, how it will be? We have 3 meter. Okay, so let me just write it properly. 1000 mm in real case will be 10 mm in my drawing. Okay, so here we have got 3000 mm. So how much it will be? It will be 30 mm. So we will be having a box here of, in actual case, 30 mm by 30 mm, representing the box of 3 meter by 3 meters. Okay, a box of 30 mm by 30 mm in the paper, which is representing a real area of 3 meter by 3 meter. So how we have scaled it down? What is the scale factor that we have used? So here is the scale factor. Here is the scale factor. So you can get like this also, that 30 mm in paper is actually 3000 mm in my real case. So 30 by 3000. So like this, then if I get, it is 100. Okay, so what is the scale factor that we have used? So it is 1 is to 100. That means 1 in real case, sorry, 1 in paper is actually 100 in real. Okay, 1 in paper, if it is 1 unit, maybe it is mm, meter, whatever it is. So 1 unit in paper is actually 100 unit in the real case. So whenever, suppose it is just given previously when we were making the drawings by hand. So in that case, what we used to do, we used to draw the drawings like this only. We used to write the dimension 30 mm by 30 mm, and then we are writing scale factor 1 is to 100. So what the engineer had to do, it he or she has to you can say scale these dimensions up by this particular scale. So whenever he or she is saying seeing that it is 30 mm, so he will be multiplying this 30 mm with 100. So you'll be getting 3000 mm in the real case. But now we do not draw the, I can say, obviously we draw the drawings in when we are plotting the drawings in the paper, we are making it like we are scaling it down, but we never write the dimensions like this. We always write the actual dimension. Okay, so that the engineer or the whoever is working for the execution, he or she does not have to use those scalings and all. Okay, so these scales are only used to, I can say, make one understand like how we have made the reduction, but the dimensions, we use the actual dimension itself. Okay, so but previously when we are drawing it manually by hand, obviously we were following this process, that we are writing the actual dimension in the drawing and we mention the scale here. Okay, then one has to multiply the scale factor with the dimension given and to find the real dimension for the execution. So it is a very tedious job it was, but now we have the softwares, we have the opportunity to make the drawings more easily. Okay, so you can understand how the scale factor is being used. So now if you just go to this you can say code SP 46, so here you can see the scale factors. So there are some standard scale factors used in most of the cases. So you can see, as I have said, expand or you can say reduction. So when you are expanding or you can say enlarging the drawing, that means whichever is some line is one, sorry, a line is of 1 mm in the real case will be represented by 10 mm in the drawing, so that we can see it in a bigger dimension or bigger size. Okay, so this is nothing but enlargement. This is nothing but enlargement. And if something is of 1 meter in the real case, which is converted to 10 in the paper, so it is nothing but my reduction. So scaling can be done in both the ways, right? So here in that case 1 has become 10 on paper, so it will be 10 is to 1, and here 1 meter has become 10 here, so I'll be converted to 1000 so here it will be 10 is to 1000. So if I just cut this, it will be 1 is to 100. So this is the reduction scale, this is the enlargement scale. Okay, so you can see the enlargement standard enlargement scales 50 is to 1. That means 50 in the you can say paper is 1 in the real case, 20 in the paper is 1 in the real case, 10 in the paper is 1 in the real case. So why I'm saying 10 or 1, this is actually 10 units is to 1 units, so it may be different unit, you can use any units actually. Then we have 5 is to 1, 2 is to 1. So these are the enlargement scales. And then we have full size, which is 1 is to 1. That means 1 in paper. If it is 1 unit in paper, the same will be 1 unit on site. So 1 meter, if it is suppose 1 on paper, the same thing 1 it will be on site when we are doing the full scale, which is 1 is to 1. Okay, then we have the reduction sizes. First we have 1 is to 2. That means if we have 1 in the paper, it will be 2 on real case or on site. Okay, then we have 1 is to 5. Similarly 1 on paper or 1 inch on paper, 5 inch on the field, right? So that's why I'm mentioning units. Actually it can be any units which is suitable for your area. Then we have 1 is to 10, 1 is to 20. Most of the cases we use 1 is to 50, 1 is to 100, 1 is to 200, 1 is to 500, like this. These are the scales mostly used actually. So again, these scales you can create as per your requirement, but whenever you are you can say making any scale, though we are writing the exact dimension, if it is 3 meter, we are writing 3 meter itself in the drawing, still you have to mention the scale. Okay, and when you are mentioning the scale and you are giving the exact dimension which is on site, then in the there is a area where you to write the notes regarding this particular drawing. So you have to write that this drawing should not be scaled. That means the scale factor you have provided here, it is just to make one understand like how you have reduced, but this scale factor should not be multiplied with the dimensions provided, because these dimensions are the actual dimensions, not the scale dimensions. Okay, but if you are providing the scale dimensions, like if you after scaling it down, it will become suppose 30 so if you are providing like this, 3 meter is represented by 30 and you are writing 30 itself in the drawing, then in that case the scale factor will be multiplied with the you can say with the actual or you can say with the dimension you have given. So in that case, in the notes, no such mention will be there. But whenever you are giving the actual dimension, it should be mentioned that the scaling should not be done, actual dimension, given dimension should be followed. Okay, so these are the things I will be explaining actually. What are the general notes we need to write? Why I am you can say mentioning those terms, because I'm considering that you guys have already got familiar with these terms during the engineering curriculum. So I'm just brushing it up to make you remember these things, so that while we will be making the drawings, it will be easy for you to understand. Okay, so this is all about the scaling, how we are scaling it up and scaling it down, and what is the need of scaling, obviously. Then the next topic I have explained or I have written here is my text and dimension sizes. So there are a few standard, you can say here, let me just see, this is a reference book I'm using. so that you can have a look. So for text and dimension sizes, you can see this is for line widths, which I'll be coming in a while. Let me go to this text here. Yes. So here you can see for text and dimensions, these are the some recommended sizes given based on the paper size you are choosing. So we have 1.8 units, or it is in mm actually, 1.8 mm, 2.5 mm, 3.5 mm, 5 mm, 6 mm, 10 mm, like this for the capital letters. Okay, so here in this table you can see for the main title of the drawing, you may use 5 mm, 7 mm, or 10 mm. You can say size of for the text. The similarly for the subtitles, it is 3.5 mm or 5 mm. For dimensions and notes, so whenever you are writing the dimension for one particular object, so it will be like 2.5 mm, 3.5 mm, and 5 mm. So these are the standard values we will be using in our drawings. But again, you need to understand, when you are making the drawing in 1:1 scale, okay, so and you will be putting this drawing on paper in 1:100 scale. So when you are scaling the drawing down to 1:100, along with this, all the texts, all the dimensions, everything will be scaling down. So this 2.5 mm actually meant to have here in 1:100 or 1:50, whatever drawing you are using. Okay, it will be like or to be more clear, this 2.5 mm should be on paper, when we are drawing 1:1 scale. It is in the software, or it is not possible to draw on the paper, right? So when we are using software has a, I can say, huge space where we can draw actually 1:1 drawings. Okay, so I'm talking in terms of software. When we are drawing it in any CAD software, we have the you can say unlimited area to draw the you can say drawings. So if you are thinking that 2 is to 5 2.5 mm it is on the real case, no, it is wrong actually. Okay, when you are making the drawing in 1:1, it can't be 2.5. It is actually on paper. Suppose you have kept the drawing in 1:100 scale, so here it should show, it should be visible as 2.5 mm height. Suppose I have written my name like this on paper, so this height should be 2.5 mm on paper when it is printed. Okay, after printing, if you measure with scale, it should be 2.5 mm. Okay, so then how we will be putting it in 1:1 scale drawing? So obviously now we need to do the reverse process. We need to scale it up in the 1:1 scale. So that means this 2.5 mm size will be multiplied with by 100. Okay, so in that case 250 mm dimension size we need to provide in the drawing that we are making in 1:1 scale. Then while plotting in the, you can say, a paper, it will become automatically, it will become 2.5 mm in our printed sheet, right? It will be visible as 2.5 mm in our printed sheet, right? Okay, so these are the things we will be following. Actually, I'm not going very deep for these things, because these things can be covered very easily in the software itself. So now for, you can say, line thickness, you can see here for line thickness also there are standards given. You can see for the line thickness 0.13, 0.18, 0.25, 0.35, 0.5. So all these line thickness are also given in AutoCAD. If anyone have any basic idea of AutoCAD, you can see this kind of line thicknesses are already given. Now again, these thicknesses should be visible on paper. So this 0.13, if you are drawing in 1:1 scale, suppose 1:1 scale, and you are plotting the drawing in 1:50, suppose, so in this 1:50 scale drawing, it should be visible as 1.3 mm. Okay, that means in the 1:1 scale drawing, we need to be scale it up, so it will be 1.3 multiplied by 50, 1.13 multiplied by 50, and whatever it comes, we need to make the dimension size as this one in our 1:1 drawing. Then while putting it on the paper, we'll be getting this 0.13 mm automatically. Okay, so these are the software. In software we'll be doing the same. Okay, so these are the line widths. Now one thing we need to keep in mind, that the BIS is recommending that the difference between two lines, suppose one we have a thick line, okay, and we have a thin line, so difference of these two lines, difference of widths, okay, difference of this thickness of these two lines, it should be at least 1:2. That means if it is, suppose this is 0.13, it should be 0.26, like this, or 0.25 you may consider. Obviously it is possible, but the code is recommending that it should be at a gap of 1:2. Okay, so then we have different type of you can say lines here and their uses. So if I jump into SP46 again, so here also you will find different type of lines. We have continuous lines, we have dashed lines, we have dash space lines. So these terms are very you can say required actually, and this is given in AutoCAD also the similar way. Okay, and if you see here, so that's why I'm recommending you to read this SP46, so that you can have a clear idea about the line thickness, the line types, and their uses. So if I just show you, we have here, let me drag it a bit down. So from here you can see the continuous lines and its uses. So for boundary of different materials in view, cut and section, okay, hatching, diagonals for indication of openings, holes and recesses, arrow lines in stair, modular grid lines, short center lines. Okay, so there are different other uses listed here in the SP46. Then you can see continuous narrow lines with zigzag. What is the use for there? Continuous wide lines. Wide line means the thickness will be a bit higher than the previous one. Then continuous extra wide lines, okay, for reinforcement bars, lines of special importance, okay, then dashed lines. So what are the uses of these lines? It is also written in SP46, and you can easily read it out from here. So that's why I'm not explaining here. You can have a look on this, so that you can have an idea while using these lines on our drawing. Okay, so now I hope every one of you have understood that why this kind of line types are given in AutoCAD or in different other CAD software, because every line has its own importance. Every thickness of line has an importance. Okay, the height of the text has an importance. Okay, so it's not like you can draw the line of any thickness, and the differences you can provide any difference. Okay, the text height you can provide any text height. So it's not like that. There are standards given for this, and you have to follow these standards to have a proper construction drawing. Okay, you may provide a drawing you can say in your site as per your you can say convenience, but it is not the standard one. When you are making a standard drawing, obviously you need to follow these rules, the basic rules at least. Obviously all the rules it is not possible to follow, it's not possible to remember always, but at least the basics one we should follow to have a proper, you can say, a neat construction drawing. Okay, so again it is the line widths. So while drawing it, we will follow these things. Actually we will see how we are drawing it. Actually these are some examples of different uses of different lines actually in different places, you can see. Okay, so I'll be attaching this SP46 in this in the course reference files, so you can download and you can have a look on this. I'll also attach this textbook. or you can have a textbook of any engineering drawing textbook, so that you can have these fundamental ideas. Now this texting things we do not require, because now we have the software, the advanced thing, and the software is capable of making these such decisions automatically. If you want to know, you can again have a look on this, but this lettering says we are not going to do manually. We don't have to make such boxes and all to make such you can say letterings now. Okay, previously we had to make these boxes to make the letterings, right? Now one more thing I will explain now. Here it is the uh, folding of those papers. Like after making the drawing, suppose we have already made the drawing and we need to fold it to send it to the site. Now it's not like you can fold it in any way, so there are also rules to fold the paper actually. Okay, so let me give one example and you can then have a look on this particular code so that you can understand it. Okay, so now I'm just giving it one example. Suppose let me go to this place. Okay, so I'm taking the biggest size, which is A0, and you can see this is the 5-fold you can say process, right? 1 2 3 4 5 6. Okay, it is having 6 folds actually. Now here the one thing you need to always keep in mind, that the title block on which the title of this drawing and other informations are written, this should be visible at the top. So you need to fold the you can say drawing in such a way that this title block should be visible. Okay, so whenever you are folding like this, see this title block is visible here. So whenever someone is getting this drawing, when he will be seeing this face of the paper, he will have a clear idea about what drawing is there in this folded paper. Okay, so because in the title block everything will be written here again. Okay, I'll be explaining about the title block also, so the basics about title block, and later I will explain about the title block when plotting the drawing. Okay, so you can see here we have 7-fold and 6-fold. How we can do actually, the first fold, second fold, third, fourth and fifth, so total will be having 6 folds, and the 7-fold is here actually. Okay, so in horizontal direction we'll be making 5 folds, and in the vertical direction we'll be making again 2 folds. Okay, so finally we'll be having a paper of like this. So when you will be sending the drawing to the you can say site, it will be just like this. Okay, folded like this, but this title box is visible, so one can easily understand what drawing it is. Okay, so now the for different paper sizes, what is the you can say fundamental dimensions you should follow. But again in the real scenario it is not possible always to get to like 210 mm like this, but the basic thing you need to keep this in mind, that the title block should be at the top. Okay, then we have this A1. For this we have this kind of folding system, then A2, A3, and A4 is not given here. So now one thing, it is very clear to you that in every case this title blocks are at the top. So even one is not unfolding the drawing, he or she can easily understand what drawing it is by seeing the title in the title block. Okay, now what is this title block, what this title block is containing? So in this book, let me go to this book, and here maybe you will have a very basic idea about the title block. Here you can see the title block. So here the drawing done by whom, at what date, checked by whom and what date, and this drawing is approved by one some authorized person, his name and date, the material, tolerance, finish. Some cases in suppose we are drawing making the structural drawing, so there will be different informations. Okay, so these informations will vary obviously. Projection, it has written, maybe it will be changing here. The legal owner, obviously it will be written who is owning this drawing or this particular structural thing we have made. The title of the drawing. Okay, the scale. Obviously now if in your drawing if there are different, suppose we have a A0 paper. Now one drawing we have at 1:100, one drawing we have 1:50. So in that case you cannot mention the scale here, right? Because we have multiple drawings of multiple scale. Previously, while we are making the drawings by hand, so it was very hard to make, like we do not know whether it is possible to make another drawing of a different scale in this paper. So most of the cases we end up providing one drawing or hardly two drawings on one paper. Okay, so if it is just one drawing, you can easily mention the scale here, right? But if there are multiple drawings and of multiple scales, then it is not possible to mention the scale here. Okay, identification number. So these things may vary, but the one thing we need to keep in mind is this dimension. For this kind of title block, this dimension should be 170, 150 to 170 mm. Okay, because the first fold that we'll be doing in any case of paper, it will be 210 mm. Okay, so this particular title block should be clearly visible even after folding. Okay, so you can already we have had a very clear idea in our engineering drawing classes. We have made it by our own, so you can see here. Then offsets from the paper directly, we cannot use the full paper. We need to left some portion on this sides, so 10 mm. Previously, while drawing the making the drawing manually, we used to leave 20 mm from this side and 10 mm from all other three sides. But now we cannot waste the paper also, we cannot waste the space also while making it in computer. So obviously we are leaving 10 mm. So you can see here, actually it is given here 20 mm for A0 and A1. If the paper size is very big, A0 and A1, so you can leave 20 mm. This is in the language of software, it is called bleed. Okay, in the language of software, this is called bleed or trim size. So this is called bleed. Here it is the offset. So this offset will be, in case of A0 and A1 paper, it will be of 20 mm, and in case of A2, A3 and A4 paper, it can be considered as 10 mm. Okay, so and inside this box we will be putting all the drawings that is required. Fine. So now I think I have covered most of the basics. Let me show you one title block which is available here. These are the texts. Now these are the actually drawings. Let me see if it is available in SP 46. Okay, so okay, I will explain, I will show that later. Actually it is possible to, because we will be making the drawing, after that we'll be needing the title block, so we can easily show it later. Again, these title blocks are not the one we'll be using in our construction drawings, so that's why I'll be explaining it later, not an issue. Now so this you can say line weights, or you can say text heights. I have already explained the standard text heights. So in this, I think this is it for this particular session. So what I will do in the next session, we will understand different rules or different local authorities. So here I have one book, the PDF of book of Tripura Building Rules 2017. So this is one book that we need to understand, and I'll be actually explaining. And then we have another rules which is for KMC, Kolkata Municipal Corporation. So it also has its own rules for making the submission drawings. Submission drawing means the drawing which you need to submit to the municipal authority for taking the approval of construction, or taking the approval of making it possible in the site, right? So obviously we cannot make a building in municipal areas or in the urban areas without taking the permission of the authority. So for taking the permission, you need to make the drawings according to these rules. So I'll be explaining these two rules. Not obviously the whole book is not possible to be explained, so only the important points that most of the cases will be requiring to make the drawings. So I'll be explaining those points from these two. You can also have you can also download your local the code of your local authority, of the local body, and you can also read it out. So the same things, whatever I'll be explaining, the basic you can say things, you can also see in your local, you can say, code, and you can make your drawings accordingly. Okay, so one thing I want to mention, that in the areas I belong to, here we'll be using the units as or meter. So either we'll be making the drawings in meter, or we'll be making the drawings in in different parts of India. We also use the inch or feet units, but we'll be using and meter throughout this course. Okay, so obviously I will also explain the conversion of the drawing from meter to inch, or meter to feet, or to inch, to feet, so that you can have a like, after watching our classes, you can also make your drawings in inches and feet also. Okay, so along with the and meter, I'll be also telling you the conversion, and what is the uh, like, what is the dimension need to be considered for different components in inches and feet also. Okay, so this is it for today's lesson. So in our next lesson, we'll be having a look on this particular books with the amendments made in these books, and the important things mentioned in these books for making a building plan or different other, like, services drawings. Okay, so thank you, and I will see you in the next lesson.